The next panel is going to be focused on infectious disease. You've already met Sania Nishtar, Kristie L, and Drew Weissman, and they're going to be joined by another Nobel laureate, Charles Rice, who was awarded the 2020 Nobel Prize in Physiology or Medicine for his role in the discovery of the hepatitis C virus. And those four are going to be moderated by Owen Gaffney, who's the Chief Impact Officer of Nobel Prize Outreach. So, over to you, Owen.
Cool, so we're going to talk about pandemics, infectious diseases, and vaccines. You know, Arundhati Roy, she said during the pandemic that a pandemic is like a portal into a new world, and it always has historically been there's been a before and after. It's changed the world. And I'm going to start with you, Sania. So, you know, what have, you know, from Garvey's perspective, you know, going through this pandemic, what have we learnt from this on how we cope, how we cooperate, how we deliver, how we develop vaccines and get them in arms, you know, and everything else that came with it?
So thank you for that question. There were many learnings from the pandemic, and those learnings were for countries, they were for different global health entities, they were for WHO, which is the steward of the response in case of a pandemic or an emergency. But from Garvey's perspective, as you've encouraged me to focus on, there were three key learnings. One of the learnings related to the timing of Garvey's response. Because when an emergency strikes and the vaccine is available in the market, you should be able to respond very quickly. And Garvey at that point recognized that we didn't have the institutional arrangements in place to do that, which is why, so based on those learnings, we created an instrument called the First Response Fund, which makes liquidity available on the day the pandemic is announced. And we actually set up the fund, and then we tested it when the Mpox emergency struck. So we were able to order the largest consignment of Mpox vaccines, 500,000 doses, just 3 days after the pre-qualification of the vaccine, and 30 days after the announcement of the emergency. So we tested the mechanisms of the instrument, and that was the first learning. And of course, a learning is useless unless you take remedial action. So just to let you know that the learning cascaded into concrete action, and that action has also been tested, as I just mentioned, during the Mpox emergency. The second learning related to the robustness of the routine immunization system. Because if routine immunization systems function, workforce, and I'm talking about workforce, supply chain, logistics, the data layer, the hardware, all the elements of the health system, if they function within countries, you can rely on them during pandemics and, you know, build surge capacity, which is why we are making enhanced investments in that area going forward. And the third learning was specific to Africa, because as you know, Africa was behind the line when it came to access to vaccines. And learning from that experience, we put in place what is called the African Vaccine Manufacturing Accelerator, which is a $1.2 billion financing facility, which is meant to act as a catalyst to signal to the investor to invest in Africa and bolster sustainable commercial vaccine manufacturing on the continent. So there were these three learnings specific to Garvey, and I'm very pleased to let you know that we've learned from those experiences. We've built the right institutional mechanisms, and we've also tested them. Excellent.
And then, so from Garvey's perspective, What are you thinking about now? What do you think are the big risks, today and over the next few years? You mentioned mpox. Where else do you see threats that can be addressed?
Well, with climate change, there are, there's no dearth of threats with climate change the way it is. We just had a brilliant presentation looking at the statistics of dengue and how alarming that is. Across the Atlantic, it's the influenza brewing up. But basically, from our perspective, we look at different scenarios and we see whether our response mechanisms are adequate for those scenarios. Number one, if there is an outbreak or an emergency and the pathogen is known and the vaccine exists in our stockpiles, how do we mobilize? The other is a situation when a pathogen is known and the vaccine exists in the market but is not in our stockpile. How are we going to get mobilized? Number three, if the pathogen is known and the vaccine is pre-qualified, is licensed by one regulator in a country but not pre-qualified by WHO, which was the scenario with mpox. How are we going to, what is it that Gavi is going to do? Vis-a-vis a situation where the vaccine is not in the market, it's in the upstream leg of development. What do we do? And a scenario when there's disease X.
Okay.
Neither the pathogen is known nor there's a vaccine. So there are different response mechanisms.
We'll come back to that. Chris, you were talking about dengue earlier, talking about malaria, Zika. Where do you think the risks are immediately that you're concerned about, and then further on this century?
One of my complaints about life is I was not issued a crystal ball. And all of us would love to have those. We don't know. And that's why the emphasis on preparedness. And two comments I'd like to add from the learnings from COVID-19. One is the importance of taking systems-based approaches, of stepping back and looking beyond health. That often health is tripped up because it didn't consider what might happen with supply chains, for example. Not in this case for Gavi, but in many cases, there just hasn't been this bigger picture. The second is the future is not going to look like the past. And to put in place the mechanisms to think about how the future is going to be very different. One thing that can be learned from military around the world is they engage in wargaming on pretty much a daily basis, recognizing that preparing for the last war is not going to help them prepare for the next one. And these are desk-based exercises looking at a range of possible futures. And often the future, even with the wargaming, isn't as extreme as what actually occurs. Yeah. And I think, for example, I live in the Pacific Northwest. The heat dome that hit us a couple of years ago was accurately forecast, but it was so extreme, nobody believed it. And those kinds of situations are happening more often. The flooding we've seen in so many countries and how that affects access to care. What that means for incubation of a variety of infectious diseases and becoming much better prepared for a range of possible futures that, frankly, humans are not very good at imagining.
Yeah. Now, Charles, as Adam said, you were awarded the Nobel Prize in Medicine and Physiology for the discovery of the virus causing hepatitis C. So tell us a little bit about, where are we? It's affecting 50 million people worldwide. Hepatitis generally affects about 300 million people. But there's no vaccine for it yet. Where are we on that path?
Yeah, certainly no vaccine yet. I think, at least in terms of treatment of hepatitis C, we now have drugs that will cure, virtually everybody that's treated. But in order to really sort of control this infection, which still persists in about 50 million people around the world, I think we all sort of generally agree that we do need, a vaccine in addition to these small molecule therapeutics. And the efforts in that have really been very disappointingly slow. And part of that had to do with, I think, trying to sort of, the major players that would be developing a vaccine were actually sort of looking at progress on the therapeutic development and saying, well, if they come up with a pill that you can take once a day for a couple months or 3 months, do we really need a vaccine? But in fact, we do really need a vaccine because, even though we have these medicines, they have not been sort of delivered to people that are in still high-risk groups for acquiring hepatitis C. And so I think now, and this is really sort of based on, some of the work that Drew and Katie and others did in terms of the COVID-19 vaccine, I think that efforts towards an HCV vaccine have been given a shot in the arm, so to speak. And there's more sort of activity in academia. And I think we feel that it is an achievable goal and one that we really need to sort of get back to working on.
But why are we specifically it's so difficult with hepatitis C compared to other viruses that we haven't made the progress, you think?
What, in terms of making a vaccine? Well, I mean, there are a couple of things that discourage people, I think, from working on a vaccine for hepatitis C. I mean, one of them is that the virus is incredibly variable. So in a single chronically infected individual, there are an estimated trillion variants generated per day, sort of multiplied by tens of millions of people that are chronically infected worldwide. So it thought that, and then there's immense variability in terms of different genotypes of the virus. So again, coming up with a broadly protective vaccine was viewed as difficult. And then the other thing is that in about 30% of the people that naturally resolve the infection, 70% become chronic. Those individuals, although they're at somewhat lower risk of getting reinfected and progressing to chronicity, they can be reinfected. So if the natural resolution of the viral disease by your immune system doesn't leave you with a protective immune response, people felt that doesn't bode well for developing a vaccine. I don't agree with that because I think, basically the methods that we use to deliver viral proteins and antigens to elicit an immune response are different in the context of some of these platforms like the lipid nanoparticle mRNA technology compared to what the virus does, which is very effective. So I think those are some of the things that, sort of said that this is going to be a challenging endeavor and maybe discourage the kind of activity that it really deserved.
Okay, now, Drew, so you developed with Katie Carico the mRNA vaccine for COVID-19, and that's built on decades of research on mRNA. But how long did it take you to create the actual vaccine for COVID-19?
So honestly, it took about 15 minutes to design the vaccine. Once the sequence was released, we made a bunch of different variants because we weren't sure which one would work best. But the advantage of RNA is you just need the sequence, and once you've got the sequence, you can make a vaccine.
So, building on that, your lab, it's astonishing how many diseases you're working on right now. I think in the last year, your lab tripled in size. Could you give us a few examples of of what you're working on, the diseases you're...
Yes, so we think of virus vaccines as there are easy ones and there are difficult ones. So HCV, influenza, HIV, malaria, TB are difficult. But we've gone beyond just standard infectious disease vaccines. We're working on vaccines for autoimmune diseases, vaccines that turn off specific immune responses. We're working on in vivo gene therapies. So what that means is instead of taking cells out of a person's body, which is difficult and expensive. We do the gene therapy in the body. We direct the lipid nanoparticles to the bone marrow stem cells or the liver or the heart or whatever organ you're treating. And you deliver Cas9 gene editing that can fix the genetic defects. So my dream 5 years from now, hopefully, is to go to somewhere, probably in Africa, but anywhere in the world, with an igloo cooler full of RNA LNPs that will cure sickle cell anemia with a single injection. And I think that's possible. Gene therapy, therapeutics using RNA is in the body. You just give the RNA LNPs and they do the work in the body, and that's critical.
And I have a list of things from your website on some of the other things you're working on: HIV, herpes, Lyme's disease, avian flu, norovirus, Ebola, and you're also working then on AI tools as well to help with discovery. And this idea of pan vaccines too. Do you want to say something about the idea there of vaccines for multiple diseases?
Yeah, so if we look at pandemics, most viral pandemics have been caused by influenza and coronaviruses. The issues with both of those is they have animal reservoirs, and we never know what the next transfer, crossover is going to be. So for influenza, we see bird flu is now infecting cattle and cattle milk. We see coronaviruses are constantly crossing over. So instead of making a new vaccine every time a virus crosses over, our idea is that we make a vaccine, one that treats all influenza viruses. So no matter what crosses over, from a bird, from a pig, from a chicken, from whatever, people will be protected. And the same with coronaviruses. We make a vaccine that protects against all coronaviruses capable of crossing over from bats. Then one vaccine either treats the next infection or prevents it from ever happening.
Now, it is remarkable, and so Sania, Chris, any reflections from your perspectives then on the potential here and the priorities before we close?
Obviously, enormous potential. It's very exciting to hear this. And looking at the upstream issues of access to care, of being able to get accurately diagnosed, doesn't exist in many places. The challenges that have been observed with the polio vaccine, because it has not been possible to have the rapid diagnostic test kits that are needed to be able to say that we have an impending epidemic, we need to take action. And so those are critical, and it's critical that they are embedded in all of the approaches we heard from Professor Marmot and others about ensuring that our systems, our governance, are appropriate to be able to address the situations as they arise.
Sania, can I give you the last word?
I think it's fascinating to hear Drew talk about the possibilities for the future, and I think there's this huge opportunity for us to exploit synergy, because different institutions have different mandates and comparative advantage, from upstream science to delivery, which is what we do. And I think we need to collaborate better and get to understand each other better. I think there's a huge opportunity that the future holds.
Okay, well, Sania, Chris, Charles, Drew, thank you so much. Okay.